This is my invention. It's called the Sky Cleaner. And what I'm going to show you on this video is how the ecosystem works with the Sky Cleaner. What it does is it removes hydrogen bubbles and static electricity from the air. And I'll explain to you how this all works. First, we've got Columbus back in 1492, 521 years ago. I'm going to teach you how static electricity is formed, hurricanes, tornadoes, lightning, what static motors are, and what hydrogen bubbles are. When Columbus first came to North America, everything was perfect, pristine. Beautiful trees, big, large trees, lots of water, lots of trees, everything was natural. The trees were really big. We have national forests now that protect some of the bigger trees, but the trees when Columbus first came here were probably all like this. The Indians lived here, and they probably used fires to help flush out their prey. When a fire would start in a grass fire, they probably just let it burn, or they try to protect their crops. But in general, they probably just let forest fires burn. They wouldn't run around on their horses and try to put out fires. They'd run from them. So everything was natural back then. This would be a good natural fire, the one here on the right. It would be burning the lower brush and the smaller limbs on the trees, so the trees would continue to grow. And then after the next round of fires, all the lower branches would be gone, and the trees could continue to get bigger. It would just continually burn the lower stuff on the ground. This is another good example of how the fire's already gone through, and the trees continue to grow. Nowadays, forest fires burn out of control. They burn the entire trees and leave nothing. The roots aren't there to protect the soil, so when it does rain, it washes all our soil away. Nowadays what we do is put out forest fires. We try to protect our property, our homes, our cities, our towns, our crops, because fires are not good for us. But it's all part of the ecosystem. Fires were very important back then, and they still are today. But that's what my Sky Cleaner is going to do, is remove the static electricity and the hydrogen bubbles. But anyhow, we would put out fires. What happens when a leaf falls off the tree, or when it's hanging on the tree still and it's drying up in the fall time? They curl up. This would be the top side of the leaf, and this would be the bottom side. You see how it forms a bowl shape, and then it forms a bowl shape, but it's upside down. The points on the would be pointing towards the ground if it's upside down. So now when the wind blows, it would catch right here and would try and flip it over to be more of a bowl shape, so it could scoot across the ground easier. As it scoots across the ground, when there's static electricity in the air, what happens is the leaves start to spin. And as a cluster of them start to spin, what they're doing is they're gathering static electricity. And what they're doing is, I call it a static motor. And as they all start to spin, that would be a static motor. And then suddenly they stop. Well, what they've done is created a hydrogen bubble. And a hydrogen bubble is invisible. You can't see it with your naked eye, but photography shows you that you can see it now with digital photography. Anyhow, the leaves spin on the ground and then stop. That's when a hydrogen bubble is born or created. You've seen it in shopping centers. The leaves start scooting across the ground, and then they get into an L-shaped corner of a building like this. We see back before Columbus came here, instead of this being a L-shaped or a inside corner, the it would have been maybe a rock cliff, a grove of trees that grew like this, or maybe cattails along the water. And then in the wintertime, when the ice freezes and the leaves blow across and hit it like cattails or grove of trees, again, they're going to spin, create a static motor, stop spinning, and hydrogen bubble is formed. So the hydrogen bubbles look like this. Now these I got off the internet. They were called orbs. Orbs is paranormal. In other words, they don't understand what they are. But I know what they are now. They're hydrogen bubbles. And hydrogen bubbles are a cluster of hydrogen atoms stuck inside the bubble. That's why it's not raining anymore, because we need 2 parts hydrogen and 1 part oxygen. If all the hydrogen or lots of the hydrogen is trapped inside the bubbles, it's not going to rain or create water because the hydrogen is trapped inside the bubbles. All these here. Now they say that the paranormal, they're in graveyards. Well, this is a graveyard, but this isn't. This is probably somebody's backyard like mine, or this is at a rock and roll concert. So the digital photography is showing us now that there's lots of these hydrogen bubbles in the air. Hurricanes. What a hurricane does is it moves inland to the south and the southeast side of a drought-stricken area. And the reason it does that is pulling in not only the hot, dry air from a drought-stricken area, what it's doing is pulling the static electricity in. Because when the leaves and the grasses are rubbing together on each other, they create more static electricity. And then as the hurricane moves in, it feeds on it. Because I've asked people who've lived through hurricanes, and I ask them about the lightning. He says, oh, there's very little lightning. But the thing they're worried about are the tornadoes. Tornadoes form because, or not so much because, well, it's because of the static electricity, but they're also drawn towards the static electricity. I've watched a lot of videos on TV on tornadoes, and the thing that surprised me the most is very little lightning is associated with a tornado. With all the debris and everything that picks up, you'd think that there'd be more lightning associated with it. I've worked with a lot of industrial applications, and I know that static electricity is formed when you pull a lot of grain through vacuum systems, and it creates a lot of static electricity. And for this much debris to be being pulled up into the air and no lightning associated with it, it really surprises me. One day I was watching TV and I realized as soon as the lightning comes out of the funnel cloud is when the funnel cloud goes up. In other words, the lightning is discharging the static electricity from the air. Lightning also starts fires, so that's part of the ecosystem. I'll be talking a whole lot more about these on more videos coming up, but this is just a brief highlight of what I've discovered. It also reflects the sunspots. Every 23 years it gets hot, then it gets hotter. Every 23 years it gets hot, and then it gets hot again every 23 years. So what's half of that? 24, 12, 11, every 11 and a half years. So what happens? The atoms are stuck inside of the hydrogen atoms are stuck inside the hydrogen bubbles, and there's billions and trillions of them. So that's why it's not raining.